Well, welcome everyone, and thank you for joining us today for the first in our Risk Assessment and Management webinar series. Today we are going to talk about old equipment, no problem, in a webinar presented by Melissa Ortner, who's joining us from California. And what we're going to cover is we're going to look at risks associated with different types of equipment used in fresh produce packing houses or growing operations, and then we're going to look at some of the strategies you can use to minimize those risks. So this webinar is produced by our Colorado Produce Safety Collaborative, and the collaborative is really a group of organizations who've come together to coordinate education. So the Colorado Fruit and Vegetable Growers Association, CSU Extension. So today you have myself, Martha Sullins, and Christy Dice here facilitating this webinar. Our other partners working through the collaborative are Fort Lewis College, Rocky Mountain Farmers Union, and the Colorado Department of Agriculture. And the goal of this collaborative is to coordinate our education and make sure that we are providing consistent and top quality educational programs to growers and other professionals around the state. And so frequently you'll see us advertise Produce Safety Alliance grower trainings, food safety plan development workshops, and hopefully a lot of other educational opportunities, including this webinar series. So without further ado, today we have with us Melissa Ortner, and she currently heads up food safety for Heinzen Manufacturing International. And Heinzen Manufacturing provides both engineering services and equipment manufacturing for the fresh produce processing industry, both domestically and abroad. Heinzen is known for the innovation and advancement of solutions that incorporate hygienic design principles. Melissa is a graduate of Cal Poly San Luis Obispo, received her bachelor's degree in dairy science in 2009 and is currently a graduate student in food safety at Michigan State University. So throughout her years at Heinzen, Melissa has developed industry tools relative to the awareness of sanitary design, both for new and legacy equipment, sharing best practices and tribal knowledge with the fresh produce industry. With her focus on continued industry education, Melissa also participates as a guest instructor for the joint PMA, so that's the Produce Marketing Association, United Fresh Produce Association Listeria workshops, which provide insight on the latest in cutting-edge hygienic design methods. So we are very fortunate to have Melissa join us today. This webinar will last about 30 minutes. We're going to save all of our questions for the end. And if you could please put those in the chat box. So if you have any questions directly for Melissa, which we hope you'll have lots of. If you have comments for us on other things you would like to see us address, we'll cover all of that in about 15 minutes at the end of this. And then this webinar is being recorded, and you can access it on the webinar tab in coproducesafety.org. All right, so I am now going to pass the screen to Melissa. So take it away.
Good morning, everyone, and thank you, Martha. Let me get my computer sharing here. All right. Share. All right, is it up and running for you?
No. I can see it on my side. Good. Say yes in the chat.
Okay, wonderful.
You're good. Yep.
Perfect. Well, thank you, everyone. Appreciate you joining us on Friday the 13th here. Heinzen Manufacturing, like Martha said, is an equipment supplier to the fresh produce industry. We've been in Gilroy, California since about 1978, so we've definitely seen some improvements as it pertains to sanitary design over the years. My biggest interest relative to equipment is the majority of equipment we have out there on the market today does have opportunities relative to sanitary design, although we don't have the opportunity to replace all that tomorrow. So there are ways to mitigate some of those risks And that is a little bit of tribal knowledge, a little bit of industry best practices that we're going to go over and wrap that up in a nutshell in the next half an hour. All right, let's see, advance here. Okay, so a little bit on the agenda. So what classifies old or legacy equipment? Typically, this is equipment that has been designed without sanitation or sanitary design in mind. So this can be either old or new. It just depends on what sanitary design features have or have not been wrapped up in that piece of equipment. What is the risk with equipment in the fresh produce industry? We have challenges with the potential for bacterial contamination, such as listeria. One of the biggest concerns in fresh produce that it has the ability to grow inside of niche points inside of equipment. And then how can we mitigate the risk today and in the future? When we go over towards the end of the presentation some of the tribal knowledge that we've learned over the years, we're going to go over some pros and cons on how to fix this, say, tomorrow or over the weekend, and how we can look at future considerations in improvements in sanitary design. So there will be a little bit of terminology that's rolled up in this presentation. So when we talk about legacy equipment, I touched on that just a slide ago, but equipment not necessarily designed with sanitary design in mind. SS will be stainless steel. FC and NFC is food contact and non-food contact surfaces. OEM is the original equipment manufacturer. So Heinzen is an original equipment manufacturer. For those of you that may run Apples, Atlas Pacific is an original equipment manufacturer. PM is preventive maintenance. Time and material is a common theme that OEMs use to, when we look at costs and considerations, T&M is time and material. So how much time is that going to take you to fix something, and what material costs may be associated with that repair? Talking about TIG weld, it's just a common weld practice in food equipment fabrication. There's also a MIG weld, but when I mention TIG weld, that's a very common stainless steel welding technique. UHMW, this is used mostly in cutting boards and slider beds of equipment. It's a very common plastic that's used on food processing equipment. SD, sanitary design, and PEC, or PEC, is your periodic equipment cleaning. So you'll see these as we move throughout the presentation today. So what do we know today? Legacy equipment definitely presents its challenges. When we look at cleaning, maintenance, there can definitely be challenges, and they're difficult to work with on a day-to-day basis. New equipment is sometimes a little scary to see that quote come through. There's a lot of money up front, and we don't all have that money to replace our equipment tomorrow, so we need to make it work today. Older or legacy equipment will eventually cost you money in the long term. So when we look at a particular design that maintenance or sanitation is having to dismantle on a weekly basis, looking at that T&M, that time and material, that it's going to cost those employees to dismantle and clean in conjunction with your cleaning chemicals, it will eventually add up money. So as we go through, you'll see there will be some justifications to how you can look at presenting this to management. When you add up those numbers, see how that compares to a newer design of equipment for future. So looking at zone definitions, I thought it was of value to touch on this, because as we look at sanitary design, focusing on zone 1 and zone 2s are probably the best place to start. So zone 4 is remote or outside of your process flow, so looking at your doorways, walls, and drains in non-processing areas. So depending on your facility layout, zone 4s can be your coal area, it could be your offices, so areas away, very far away from product, and the likelihood of contamination to a zone 3 is probably more likely than directly to a Zone 1. Zone 3s are your semi-remote, semi-processing. So this could be inside of your raw room, inside of receiving, pack out areas and shipping, looking at floors, walls, forklifts, etc. So with each of these zones, they're defined as the probability to cross-contaminate to the next zone. So for example, when we move on to Zone 2, the likelihood that they're going to contaminate Zone 1 is much more common than a Zone 3 directly contaminating a Zone 1. So Zone 2's very common on produce processing equipment. It's areas directly below the food contact area, such as equipment legs. It could be your floors and drains. So depending on the close proximity of that belt, that product contact belt to your floor or right to your drain, that could be considered a Zone 2 surface, which is sometimes a little scary to look at, but it all depends on installation proximity. Control panels. So when we look at our MCC control panels, does an employee go and touch that button to turn that piece of equipment on, and then they go to a particular broccoli line and start to sort broccoli? Very close areas that could potentially contaminate Zone 1 surfaces. Zone 1, we move to the food contact surface. So those are your belts, your rollers, your utensils, your incidental product contact surfaces. So we like to say anything that can drip, drain, drawn, or diffuse onto your product contact surface. So a consideration is the underneath of your belt a food contact surface? Well, yes, because that belt is continually moving around and it does have the potential to drip on either a belt that's underneath it, or when it goes around the pulley or the sprocket, is there the potential for that to get on your food contact surface? Another consideration is, could your ceiling, your lights, be a food contact surface? Again, that depends. So if you have condensation or whatnot that's on your ceiling that has the potential to drop directly on your belt, then yes. There have been times that, say, a ceiling is chipping paint or whatnot, and given enough vibration, that paint falls onto a belt. So look what's above it. Look what has the potential to spray onto that belt. But all things to look at when you're looking at your Zone 1 surfaces. So the importance of sanitary design. This is a produce spin dryer, very common in the fresh produce industry, designed by Heinz Manufacturing. A tried and true design that's been used for the past over 20 years now. It's since been redesigned to aid in cleaning for numerous reasons, but one is if you look at the zoomed in pictures of the lid itself, you can see there's areas in there that are very challenging to get in there and clean without tools in order for disassembly. But this particular design required that, we call that the spider plate, where it looks like a star on that lid. That would have to be unbolted on a periodic basis in order for cleaning. So the environment that we work with in the fresh produce industry is conducive for Listeria to grow. Number one, by its ability for movement. So we have a lot of water in fresh produce in the fresh produce industry. This water allows movement. And then with the debris and the product itself, it allows a food source for that Listeria to grow inside of niche points of equipment. So we're going to touch on that a little bit later on in the presentation. With the labor availability we're seeing in our industry today, it's challenging to get people in that want to work during sanitation. It's cold, it's wet, usually in the middle of the night. It's challenging for labor in general, but then to keep consistent sanitation employees is key. There was a sanitation consultant that I work with periodically, and I love his analogy is, who's paid more, your forklift drivers or your sanitation employees? You know, they have a difficult environment to work in, so we need to keep that keep that in the forefront to see how we can continue to keep those employees. Shortage of time, production days are continually getting longer. So luckily, people are continuing to eat fresh produce, and the industry is continuing to grow, which makes production days longer. And sanitation maintenance times are getting shorter. So if you're running a 2-shift operation, that's 10 hours a day. Sanitation is required to clean that facility in 4 hours, depending on how production left it beforehand. And again, with maintenance, when do they get in there to clean? Do they get in there, or to maintain the equipment? So if they get in there before sanitation, if they have to change a belt or increase a bearing or whatnot, how much time is that taken away from sanitation before they start their cleaning process? So looking at certain niche points that may allow Listeria to move throughout both the equipment, product flow, and facility. Laminations. Laminations are known to harbor bacteria. So for example, if you put your 2 hands together, that area between your 2 hands is considered a lamination. So pretty common with equipment that used to move back and forth to Yuma. It would be unbolted and sent down to Yuma or back up to the Salinas Valley. So these bolt connections are where 2 pieces of stainless steel are bolted together. That is an area, and a sandwich joint, another common terminology for that. But wherever you can stick a piece of paper between 2 surfaces is considered a lamination. Surface finishes. So we've all seen a lot of poor welds out there. Those are rough, and they can harbor bacteria as well as damage your product. Poor quality of plastic and stainless steel cut-ins. So whether it's cut on a water jet or laser, depending on the speed that particular part is being cut, those little ridges on there do have the potential to make it difficult to clean. Corrosion. If you have a piece of equipment or infrastructure in your facility that may be rusting, very, very porous surface. There was a particular piece of equipment that I worked with back in the day. It was a small floor scale and not of stainless steel construction, and we had a Listeria issue with this. You lift that up and you could almost just scratch it with your nails. It was so porous and so rusted. And that was positive for Listeria. Penetrated hollow areas. Tubing is used a lot in equipment. It's quick and easy to work with. So a lot of equipment back in the day was, and still a little bit today, but was used with square tubing. The issue with that, because it's easy to work with, maintenance would go and say we needed to bolt on a hanger for something, for a particular utensil, pop a rivet through to hang a sign. When in the event that's, those are removed, you've now penetrated that tube and it's allowing water, debris, whatnot accumulation. Hollow areas also, bins and totes, as well as utensils. Some of these may be hollow, and looking at the general maintenance of these is very important, just to see if they are filling with water, if they are filling with debris, making sure that they're not being dumped onto product in the event that they are penetrated. Control panels. Control panels are known to condensate just because it is all the electronics in that particular control panel are running a little bit warmer just due to the general nature of them. So they have the possibility to condensate inside. And again, with unmaintained buttons and gaskets, water can be getting inside that control panel, which water and electricity can never be a good mix. And looking at your equipment anchoring, so this bottom picture here is we were starting to anchor down equipment, and the slab was actually penetrated prior to us drilling in here, causing water to come out from underneath the slab. So as equipment gets anchored down, knowing the depth of your slab is going to prevent water going basically in that hole and outside of that hole, because what's under your slab is typically dirt. So just a general consideration when you look at equipment anchoring. So a little bit, Heinzen and Channelized Solutions, we love to capture tribal knowledge and share that with our customers, with industry, in order to give them tools to make their best decisions when it comes to equipment, both new and old. So all of this is available on our website. Looking at newer equipment, we've developed our OEM design guide. And we're going to touch a little bit on this and wrapping in both of these guidance for you. But the OEM design guide is a black and white guide to make considerations for new equipment easier. And our learnings from legacy equipment, if there's anything else you would like to see, if you want some, if you have a particular component that you want to see some options for, that's what we like to capture. So for example, if you have hollow rollers, though not ideal, but we do have to work with them, we've given some consideration on pros and cons for different ways to retrofit. So I encourage you to have a look at that when in the event you get a chance. So we're going to go over some common equipment struggles that we get a lot of questions from customers on how do we fix this or how do we fix this tomorrow. So these three categories we're going to focus on today. So fabricated weldments, think of that as the frame of your car or the conveyor belt with nothing else on it except for a frame of stainless steel. Then we're going to move on to drive components. So if you add a drive component onto the frame of your car, you have a motor. So this will be like your motors, your gearboxes, anything that makes that particular equipment move. And belting. There's always a love-hate relationship with belting because it does seem to degrade. It does seem to not track properly where we have shredding. So we're going to go over some thought points as it pertains to that. So within fabricated weldments, we're going to touch on just welding in general because that is a popular topic that we have to work with quite frequently. A little bit on tube construction, some equipment issues as it pertains to cracking. Does stainless steel rust? Yes, it can. So we're going to touch on that. And also some painted components and painted equipment and how you best make best decisions for that. So we're looking at welding that may not, I guess, not so ideal welding. Before we want to grind it and make it smooth, we need to evaluate that weld for structure, quality, and integrity. So that weld bead, making how it's raised, if you take that off, grind that off, you're taking out some of the structure. So the best way is to just evaluate and see what that particular weld is supposed to be holding. After you've done that and you have determined that you can fix this, we're going to TIG wash it. So for example, this is a weld that we want to make a little bit smoother. So what we do is we're going to TIG wash it to make it much smoother. What this is envision it as pretty rough hot glue, and you want to melt this down to make it smoother. So you put some heat to that hot glue, and it's going to melt again and lay out a little smoother. So that's what TIG washing is. It's quick and easy to do if you have a good welder in-house. But a con for this is it could negatively impact the quality or structure of the weld. So as you reheat this weld, it could potentially make it more brittle. So the function of it is not going to be as ideal as it was previously. So having a trained welder in-house, a qualified welder in-house is very important. Another option is, say you have two pieces of metal that are welded together, and you can cut out that middle part and put a new piece of stainless in place to either replace that or move the weld location. A pro to this is a smoother weld will be easier to clean and maintain, but a con with this is the surface may warp, causing the uneven surfaces that can lead to water or product pooling. So this has happened before quite frequently on scale decks. So if the facility wants to clean up a weld or, add more material to this particular scale deck, at times you see where water starts to pool. There's little divots inside of that stainless steel platform. That's where you see that warping. Stainless steel is very susceptible to warping because it is very soft. So having that as a consideration when you start this. So tube construction, again, with holes drilled inside of this, it has the potential to accumulate debris. So with any tube construction that you may see potentially penetrated, inspect for penetrations, and you can drain at the base. So if you know that this is filled with water, you can drill a hole on the very bottom and allow that debris and water to release from that tube, and then you just plug weld it. So you take a welder and fill in those holes to reduce any potential additional debris that may be inside of there. However, if you decide to drain this, have a consideration for what may be inside of that tube. So where is that water going to go? How is sanitation going to clean that tube after that water's been, or how are they going to clean that area after that water and debris has been released? Very important, because you don't, it's difficult to say how long that debris and water has been inside of there and what can be growing inside. Another option, especially with newer equipment, is having open channel construction. So you can see the picture on the lower right. That is open channel construction versus tube. So it's now formed sheet metal where there is no potential for water and debris to accumulate inside. That is easier to clean with little maintenance associated with it, but it can be expensive. So when you move from a formed open channel construction, or you move from tube to open channel construction, engineering will be required to ensure its strength is adequate to that of the tube construction prior to that. So if we see equipment that may be cracking, something like this, for instance. So this was a dryer, a small spin dryer that was actually put on higher feet to make it easier for the employees. But the issue with that is the dynamics of the equipment have changed. So certain equipment is designed to be at a certain height. So as it moves, it's designed for that certain height. So as we lift it, it's changing the dynamic and causing the equipment to be stressed more, if you will, which can cause cracking. But if we do see cracking, we need to determine the root cause. A quick and easy fix to prevent this from cracking further is to drill a hole at the end of the crack. It stops it. And to fix this, we need to grind out the material for the weld to ensure it penetrates. So for example, this is a fix to that particular crack, but just temporarily. So if we've determined the root cause may be height, it's going to continue to crack if that's not fixed. Rusting. We all like to say stainless steel doesn't rust, but it does have the potential. There's two types of rusting. In these two pictures, you'll see what's called surface rusting. So if your facility is running a chlorine-based sanitizer, and the equipment is being cleaned on a regular basis, but some equipment, such as the scale deck on the lower picture, it can be out of sight, out of mind, may not be cleaned as frequent as some of your other pieces of equipment. They do develop a surface rust. So this can easily be cleaned by using like a pickling paste or certain acids that your chemical supplier may recommend. But it's fairly easy to remove and keep at bay. Another issue as it pertains to welds, so as soon as you apply heat or damage that stainless steel surface, it is exposing it to rusting. So again, the acids that you use to keep the surface rusting at bay help the stainless steel keep their passive layer. So it's a protective layer that keeps the stainless from rusting. Your chemical suppliers are great resources as it pertains to keeping the stainless steel how it should be maintained. and keeping rusting at a minimum. Painted components were very common back in the day. There's still some painted components out there, but more stainless steel is available, but it is more expensive. So if we want to move over from a painted motor to a stainless steel motor, there's a pretty price that's associated with that change in components. One important thing to note is equipment is very old and there's the potential of lead-based paint. Just to ensure if you're going to remove this or dispose of it, just ensure that it is taken care of properly. A quick and easy option for working with, say, if we have chipping paint on a particular component, it can easily be stripped and repainted. So that can be very common on bollards on sides of doors in processing facilities where they may get nicked by forklifts, or you know, they're repainted every year before an audit. Very easy to take care of. However, it could peel and chip again, and if you have mild steel construction underneath that paint, it's going to continue to corrode. Another option is powder coating. We've seen customers that are now powder coating components and control panels. It's stronger than paint and requires less maintenance. But the tricky part of this is typically it has to leave your facility and go to, you know, another shop to get powder coated. So that's an option as well if you have mild steel construction that you want to be coated instead of getting stainless steel. And then the third option is you could replace it with stainless. It is, again, it is probably the most expensive option. You won't need to recoat it over the course of its life, or you shouldn't have to if it's maintained properly. But it is going to take some time to get it built, installed, and components sourced. So hollow rollers, we're going to touch on hollow rollers a little bit. It's definitely a love-hate relationship with hollow rollers. They're cheap and easy. Their maintenance loves, to buy them and replace them because they are easy. But again, they're hollow, so they do have the potential to expand and contract. And also if they, for some reason, a piece of debris gets in between that bearing, they can stop rolling. It stops them, and as the belt rides over it, it has the potential to damage it and water accumulation inside. So an easy way to fix this is to replace them at defined frequencies. So say you have this on a food contact surface. In your studies, you've seen that every month they start to show wear. Okay, that's when I'm going to replace all of these. But however, you may not catch all the penetrations or damage, and there is the potential for those to fill up with water and debris. Another option is to replace these with solid rollers. A consideration for these is you may get lucky and it may be a direct replacement if these are an idler or a return roller. But however, if these are drive rollers and you're making them a little bit heavier, so say you have 20, just for example, 20 PVC hollow rollers on this line, and now I want to replace this with 20 solid rollers on this line that are now 5 pounds each versus 1 pound each. The motor is going to have to work a lot harder to drive these. So ensure that the OEM, the manufacturer, is involved with these considerations. They can help you make the best recommendations possible. Easier said than done is we can always replace the conveyor for something that may be of more sanitary design. Not only may the rollers be more sanitary, but there may be additional sanitary changes in this conveyor. May be expensive, although like we talked about earlier, is weigh out the cost of sanitation, maintenance, time, and material in order to say you're changing these rollers at certain frequencies. So looking at belting, different types of belting out there, and it's sometimes it's easy to replace, sometimes it's not. But where we have frayed and damaged belting, there is the potential for bacteria to get inside of some of those fibers that may be inside of that belt. And depending on the belt type, very quick and easy to mitigate some of this side fraying is to run a knife down the side of the belt with a torch on one side and you can melt it. That's a very quick and easy thing to do. You know, if you've noticed this issue and we need to fix it today before we get a belt next week, it's very easy to do. But it's only a temporary fix, and if we're cutting the sides of the belt, it's going to make it smaller in width, so there may be the potential for it not to track properly. So all considerations before you decide to go in that direction. We could replace the belt for the exact same type that we have if we have it in stock. That's pretty easy. But have a look, see if it's the right belt for that application. So again, the serial number on the piece of equipment, get in contact with a manufacturer if you're continually having issues with belt fraying. And we can always replace with a new belt design. It's going to be your most expensive option, but then again, if you're continually replacing this belt, you know, my grandfather always used to tell me we can't afford cheap tools. So if there's a cheaper belt that you're continually buying, is that costing you more money than getting a more maintenance-friendly design in the long run? Cap strip and slider bed. So cap strip, this allowed the conveyor belt to ride over the weldment with little damage to the weldment itself. So UHMW is the white pieces that you see in this picture. It wears better than stainless steel. So that's why you typically see UHMW slider beds on equipment. The cap strip was very common, and you can see in the upper picture on how it would have to pop off, and that gives a big lamination underneath that for cleaning. This looks easier to pop off because there's no belt on it, but as you have the belt on top of it, it's difficult to take off and put back on. You can, and you know, it's easier said than done, but remove the hardware and UHMW on a periodic basis for cleaning. It can be conducted in-house, but it may be time-consuming, especially if you need sanitation maintenance doing this regularly. It's easy to say on one piece of equipment, but if you have 5 pieces of the same equipment, that's going to add that much more time. There's an option to replace the slider bed, so that can be cut out and it can be retrofitted, but again, the manufacturer is going to have more options for you. And then replacing the equipment, the most expensive option, but weigh out your time and material. Different types of lacing. I just thought this was a good slide to show because there are different considerations with each type of lacing that you choose for belts. The clipper lacing is the easiest to apply and the least expensive. So this is very maintenance friendly. Inside of the shop, they can slap this lacing on and put the belt on in a relatively quick amount of time. The alligator lacing, some customers like this better. It appears cleaner because we're not seeing the little pieces of staple coming out of the clipper lacing. It is smoother, but it does have more laminations between each of those clips for product and debris to accumulate. There's a thermolace option now through Intralock that appears to be the cleanest of lacings available on the market today. This is challenging because it's factory installed. So if there's a local shop that you need to purchase a belt from, this type of lacing is not as easy to work with because it does have to be specially ordered from the manufacturer. And also a vulcanized or endless belt. So if you see these two pictures, it's very difficult to take a picture of a vulcanized belt because it's endless. So they'll splice it, which you see where it looks like it's cut into zigzags, and then they actually melt it together. So it's endless. The only issue with this is how do you take the belt off? If you want to take the belt off, you're going to have to cut this belt and get it re-spliced. So there are third parties that do this, but it requires sanitary design features to be built in the conveyor in order for you to clean underneath that belt. And this is some available guidance on sanitary design. So we have, like I mentioned earlier, the OEM design guide. and our learnings from legacy equipment, which is very fun to go through and kind of guides you into some best practices on how to work with legacy equipment. There's also the American Meat Institute Sanitary Design Checklist, the Grocery Manufacturers Sanitary Design Checklist, Commercial Food Sanitation Sanitary Design Checklist, and the ISPA Sanitary Equipment Design Buying Guide and Checklist. All resources for you to have a look at should you want to learn more about sanitary design. So what have we learned today? Sanitary design, whether it's new or old, is a give and take. So if operations wants to keep this piece of equipment running, sanitation and maintenance are going to have to put more time to this. So we can't get what we want today, but how do we work with it in order to get there tomorrow? It's definitely a collaboration of all departments, including OEMs, for best practices and guidance. So maintenance, sanitation, OEMs, production, all need to get together, whether it's whether it's an old piece of equipment, whether it's a new piece of equipment. How do we make the best decisions as it pertains to equipment? And there's always a way to make sanitary design a little bit better before we need to replace that piece of equipment. Ask questions. OEMs are always great resources as it pertains to what they've seen out there. They do have install groups that go out to different customers' facilities, and there may be more creative ways to make this a little bit better. I appreciate all your time today in review of this presentation, and if there's any questions, I'll be happy to answer them for you.
Great. Thank you so much, Melissa. I think we are going to go through the chat now. If everybody could just put their questions in the chat, that would be great.
So while we're waiting, Melissa, we do have a question. What guidance do you have for how to evaluate the success of altering a weld? How do you know if smoothing or replacing it might compromise the equipment function?
Weld color is a good general guidance to look at. So we want a weld that may be of gold color when it's applied. So something that may be very dark is burning through the material. So there are some guidance out there, and I'm happy to send some to you as Christy and Martha if that helps. But looking at weld quality and looking at that weld color is probably the most ideal, as well as looking at your penetration of the weld in general.
Yeah, if you wanted to send that guidance to us, that'd be excellent. We can post that on the website with the recording.
Absolutely.
So while we're waiting for additional questions from our audience, I have a question that I encountered when I was out visiting a grower. So they had a food contact surface that the paint was chipping off of, and they inquired about, sanding it down and then using a Rust-Oleum type paint product. Do you know, is that food grade? Can they use that? Like, what would your recommendation be for the type of paint that they would use on that?
I have not seen any paint that's approved for food contact surface. A lot of people are getting away from a painted food contact surface just due to the risk of chipping and paint falling into the product itself. So something like that, you could see what can be put on top of that surface that can be removed for cleaning. Or it's difficult to say without seeing it, but seeing how you can run the food contact surface onto something that may not be painted, basically diverting it if you had to, temporarily.
Okay. Would you recommend ever just sanding it down periodically so that it's smooth and just not repainting it, or what do you?
If it's a stainless steel surface, and I'm not sure why they may have painted a stainless steel surface, but getting that paint off of there would probably be ideal. However, if you have a mild steel or not cast iron, we've seen that before, but mild steel surface, it does lead itself to be very porous. So just trying to determine how to reduce that porous surface at all possible. Maybe it's something to cut that out and put, you know, a piece of stainless in that area may probably be the quickest retrofit.
Excellent. I don't see any more questions. So we have, Martha and I have a couple more that we thought might be helpful for you to address. How often should growers clean and sanitize their equipment?
That's a big it depends answer. So your cleaning and sanitizing will depend on the amount of debris that you see over the course of a particular production day or a production month, however you define it. Your environmental monitoring program will tell you how often you should clean. Getting your chemical suppliers involved as well will help you determine that baseline. And you know, whether you're looking at APC counts, whether you're looking at coliform counts, determining what is acceptable. If an OEM is telling you you should be washing this monthly, you know, they don't know your operation as well as you do. So determining what's acceptable on your end is key.
Excellent. All right, we do have a question from one of our attendees. They want to know, what are some good substitutes to foam rollers and pads used in many fruit types of equipment?
Good question. Very good question. There are, nowadays, I mean, working with certain belting suppliers, there are different belts out there that are made for a very delicate product. Also looking at having an extra clean set in place in order to switch these out at defined frequencies, similar to that of like Apple brushes. They're challenging to clean, and they're not the most ideal as it pertains to sanitary design. There's not a great, perfect design out there today. So just using your environmental monitoring program to tell you how often you need to switch those out and having an extra set in place is current best practice. Excellent.
We're not seeing any more questions from our growers, so let me ask one final question of you. Does Heinzen come out and do consulting for growers? And if so, how can growers schedule an appointment for a consultation?
Through our Channelized and Integrated Solutions team, we conduct sanitary design risk assessment. So think of it as an internal audit that does a deep dive into your equipment. So we really look at how to disassemble this, how to reassemble this for sanitation, what's the practicality of doing that. But we do go through and assess that equipment and your procedures for that, and also give you some ideas on how to make this a little bit better. So reaching out to myself, the email is provided on the presentation, or also going through the Contact Us page on the Heinzen website, would be able to get that scheduled and get an evaluation done of 1 or 20 pieces of equipment that you would like evaluated.
Great. Okay, well, thank you so much, Melissa. And we are still looking for questions if there are any late breaking ones, but barring none, we will wrap up. And just wanted to mention, if any of you out there have, if you have questions that you'd like to ask afterward, feel free to send them to either Christy or myself. Melissa, are you open for a couple of questions via email?
Yes, absolutely.
Okay, I may have a question here. Hold on, let me check that.
So the question is, can we share the resource list? Yes, we will share that, and we will post that on our website with the recording as well.
Okay, great. And let me just make sure we've addressed all of our questions. We don't want to let you go here until we make sure. Okay. Oh, we do have a question here. Here's another question. Sorry.
So, bearing design, roller versus the UHMW, what are their relative risks?
Good question. There's different considerations for rollers. So we've seen people, if this is a return roller, so which means it's just supporting the belt as it's rolling, it's not using any drive components, you can change over the PVC roller to a solid bar with UHMW discs on it. That's been a easy retrofit. But you know, it's weighing out how often you're going to be maintaining, how often you're going to be cleaning a particular roller in order to make the best judgment call for your particular facility. But that's what we look at through Channelized Solutions. So when we evaluate a piece of equipment, if we see a very lightweight piece of equipment that has foot pads that are 1 square foot, why? You know, why do we have them that big? Can we reduce that lamination on the floor to make that area a little bit cleanable? So I guess that goes into your PVC rollers or slider bed. It also is going to be also take into consideration your belting type. So and the weight of particular product on that belt is all going to determine which type of belt support you utilize.
Great, thank you so much. All right, well, now we have run through all of the questions, so we really appreciate everybody, your attention, and Melissa, we really appreciate your time on this webinar with us. So thank you so much, and stay tuned, everybody. We will be offering some more webinars, and at this time, we will end the recording and end the webinar. So thank you very much, everybody.